Your homework is a couple of these. So that would be a good thing for you to do too, to help you practice. All right. All right, so let's do just the front one, the one that has a little heart up in the corner. Here we go. What do I do first? Got this big problem here. How do I start? Factor, absolutely. And factoring is so very important, you guys. We need to be sure that we have factored correctly so that we get all of this stuff right, because this stuff all depends on the factoring. Okay, so does anybody know how the top factors?
Plus x plus 5, x minus 2.
X plus 5, x minus 2. And it takes, 30 seconds, but I'm going to go ahead and multiply this back together. So first, outside, inside, last. Does that add up to what I needed it to add up to? Done. Top is correct. All right, now what do you notice about the bottom? Be careful, it's a little bit trickier. What do you notice about it? You can take a 2 out. Your life is going to be easier if you take out the GCF. And since they all have a 2, greatest common factor, GCF, we'll pull that 2 out. And then I have this to factor. Now, the 2 must stay in the problem. You can't lose the 2. But now you're going to factor this. So does anybody know how that factors?
X plus minus.
X plus x minus, you say? Okay.
2 and 1, but it should be -2, +1.
Perfect. Now, I think that's right. He was logicking it out in his head. I'm going to FOIL it and make sure, because this is a guess and check. Factoring is a guess and check. So here we go. I get x squared minus 2 plus 1 minus 2. Does that add up? Yep. So now we are factored. So I'm going to erase my check so it doesn't confuse me. Now we're factored. What do you notice about it? We're going to be able to cancel something out, which means we're going to have a hole in our picture. I'll deal with that in a minute. I'm going to write down my problem. I have x plus 5 over 2x plus 1. This becomes what I'm graphing. Okay? Now, where is that hole going to be? Well, it's going to be where x is 2. The hole happens at whatever x value you canceled out. Well, you canceled out a 2. So my hole is going to be at 2 comma something, because that's what I canceled out. How do I find the something? Plug it in to this right here. Don't go back to the original. Once you have canceled, this is where we're looking now. So I'm going to plug 2 in. So what do I have on the top? 7. Put 2 in. What do I have on the bottom? 6. So in my picture, at 2 comma 7 6, I'm going to put a little open circle. If you're struggling with where to put 7 6, change it to a mixed number. 1 and 7 6, or 1 and 1 6. All right, now I gotta fill in everything else. So tell me what else can I put in? Well, the list is right there on your quiz. It's also up there on the board, but this won't be here tomorrow. But that list will be right there. So how do we find that stuff? Vertical, asymptote at x equals 1, that's exactly right. How did he know the oh, no, not 1, actually -1, yeah. We have a vertical asymptote at -1, because that is what makes the denominator 0. All right, what else do we have? Cindy?
The horizontal is 0.
Actually, it's not, Cindy. Actually, the horizontal is gonna be what? 1/2. Cause it's 1x over 2x. So my horizontal asymptote is 1/2. Now, can it be 0 in some problems? Absolutely. But it isn't in this one. Okay. What else? What makes the numerator 0? So 1, 2, 3, 4, -5 out here. That's called my x-intercept. And what do I get if I put in zeros? Put in 0, what do you get on the top? 5. What do you get on the bottom? 2. So 5 over 2, so 0, 5 over 2, which again, if you want, change that to 2.5, and that's your y-intercept. So now, hopefully, you have filled in all of this. This is your y-intercept, it's on the y-axis. This is your x-intercept, it's on the x-axis. That's your whole vertical asymptote, horizontal asymptote. So now you gotta sketch it in. Can you see what it looks like? It's gonna be a reciprocal function. I promise I'm not giving you any, we looked at some weird ones yesterday. we're not doing any of the weird ones. It's gonna be a nice, normal, reciprocal type function. So you've got that piece right there. Make sure you're going through your 2 points. And then what about this guy? What's he going to do? Same thing, only he's going through that point, so make sure you get that point on your way down. And there it is. Okay, any question about that? All right, let's do the back side of that. We'll practice another one on the back side. And I'm gonna go ahead and erase this list to give myself a little more room. If you have your paper that you wrote all these hints down on, you can have that out certainly today as we practice. But our goal is to start getting those memorized so that you know how to find a vertical asymptote. All right, so here we go. This is the one that's got the little star up in the corner. How do we start? Start by factoring, right? So what can you do on the top? Take out a 3, and I would definitely do that. It's going to make your life easy if you take out the 3, because what do you notice? Difference of squares. So keep the 3, and then you have x plus 3, x minus 3. need to check that one because I factored the difference of squares a lot. So I know, that's right, x plus 3x minus 3. Okay, now what? What about the denominator? We're gonna factor it, absolutely. There's no GCF, so we're just gonna factor it. X
6 and negative 3.
is gonna be 6 and 3. So you said plus 6 minus 3, Sincere?
Yeah.
All right, not that I don't trust Sincere, but I'm going to check it just to make absolutely sure. So first, outside, inside, last. I think he's right, do you?
Yeah.
What do you notice then?
There's a row.
You can cancel this. So now I'm going to rewrite my problem. So y equals 3x plus 3 over x plus 6. This is now my problem. Before I forget, I'm gonna go ahead and put my hole on my graph. My hole is a point. Where will it be?
3.
So the x coordinate's gonna be 3. Everybody agree with that? Now how do I find the y?
Negative 3.
Plug it in, so here we go. If I plug it in, I'm gonna have 3 times 3 plus 3 is 6 over 9.
2.
Did you get 2? So I have a hole at 3 comma 2. So down here at the bottom, where's this hole? You're gonna write 3 comma 2. And then on your picture, you're gonna put a hole there and label it 3 comma 2. All right, then start filling in the rest of it. You got your list right down here. So this is the stuff you have to find. So what do you want to put in? Where? Negative 6. So 1, 2, 3, 4, 5. Negative 6. Because vertical asymptotes come where the denominator is 0, right? Perfect. All right, what else? Where's your horizontal asymptote?
9 over 6.
Okay, now be careful, not the horizontal asymptote, the y-intercept. The y-intercept would be that, because if you put 0 in, you get 9 over 6. So the y-intercept, if you put 0 in for x, you get 9 over 6, which reduces to
3.
No.
No.
3 halves. So I'm actually gonna plot the point 0, 3 halves, but it is 9 over 6, that's what you get. So that's 1 1/2. So here's my y-intercept. When you let x be 0, that means you're gonna be on the y-axis. That's your y-intercept. Now what about the horizontal asymptote?
3. I got 3.
How many x's do you have on top? 3 x's? How many on the bottom? 3 over 1 is 3. So your horizontal asymptote is at y equals 3. Okay? What am I missing? X-intercept. What's my x-intercept? What number would you put into the numerator that would give you 0? What would make the numerator 0? Negative 3. So 1, 2, negative 3. If you put negative 3, won't that be 0? That's your x-intercept. Whatever makes the numerator 0. Well, that's it. You should have all those blanks filled in down here at the bottom. got them all filled in, so now we have to draw the picture. See these 3 dots right here? Doesn't it make sense that that's what we have down there? Don't stop. What else does this picture have? It has the other part, and where's the other part going to be? Opposite corner, right? So for me, it's kind of a small space up here, but this is where it's gonna be. Would everybody agree with that? Can you see that? This is where your asymptotes cross. So the pieces of the graph are across from each other diagonally. So if I've got this one down here, then the other one's gonna be up here. Okay? All right, I'm gonna hand back some tests now. While I'm doing that, would you do start the next one on your own? So it doesn't have a little symbol, but it's just the next problem. It says, who are you? You are awesome at the top. So try that one. Get that one started while I'm turning back some papers. And then we'll get started on our next lesson a little bit. I will be picking your tests back up. So please don't put those away. You can put the papers away, but you'll need your tests back again. So there's that test. So we have already done those first 2, and now we're doing this one while I am handing out some papers. Hurry up, leave your phone here. Some notes in here. Actually, I'm gonna return your last test, see if it's coming back to you. I will leave both of them back. Okay, look at those for a second. come around and get those tests, and then we're gonna work through this last problem, okay? Taking both of them. All right, how far did you get? Tell me what you came up with. Did you at least get the thing factored? How did you factor it?
Which part?
What's the top? X
X squared
plus, no, I know what the problem is. What is your factoring? X
X plus
plus,
5,
X plus
Five.
X minus 1.
okay, how does that look to everybody? Correct?
Yeah.
All right, how about the bottom?
X minus 2.
X minus 1? Step 1 complete. You've got to factor correctly. So, hopefully you check those to make sure. I did in my head, they're correct. So did you notice you had it canceled? So now your problem is really x plus 5 over x minus 2. But you're going to have, because you canceled, you're going to have a hole where?
At -1 4/3.
Be careful.
One.
Positive, want to be positive 1?
One.
Negative.
Kids, the hole is a positive 1?
Yeah.
Okay, and then when we put in 1, we get 6 over negative 6? How many got a hole there? Perfect. So I'm gonna plot it 1, negative 6. All right, where'd you put your vertical asymptote?
At 2.
At x equals 2? Because that's what makes the denominator 0. Right? Where'd you put your horizontal asymptote?
At 1.
At 1. Because you have x over x. That's your horizontal asymptote. What about your x-intercept? Where did you put your x-intercept? What makes the top 0? Negative 5. What's your y-intercept? What do you get if you plug in 0? No, if you plug in 0, you get 5 on the top and negative 2 on the bottom, right? So it's 5 over negative 2. So 0, negative 5 halves, or negative 2 1/2. Now are things shaping up like you would hope the picture would shape up?
Yeah.
We connect these. Whoops, here's my point. We connect these. And then what? Don't forget, there's another piece. And the other piece is gonna be right up here. Okay? Now, we're not gonna do the last one. If you wanna come into office hours tomorrow, we'll do that last one in office hours. You can work on it at home and check it with me tomorrow. That would probably be the best idea. For sure. But Alright, let's get our notes out. What does our quiz on Thursday look like, guys?
One question.
One problem, just like this. We just did 3 quizzes. Okay? So if you haven't yet memorized those things that I had written right here, like, how do you get a vertical asymptote? Let the denominator be 0. How do you get a horizontal asymptote? Box in the x's. If you haven't memorized those yet, you better get those figured out. Because once you get those, then it was easy, right, to draw the picture. Okay. I want to say one more time, in our notes, we had some weird pictures. Remember the ones that had 2 asymptotes and squiggly in between them or whatever? Your quiz is not that. Your quiz is just like these. So it's going to be a reciprocal shape. Piece like this, piece like this. Okay? Just like these. All right, we're going to do a few. We have shortened period today. We're going to do a few from section 2.7, which actually, I think you probably already know how to do these problems. So here's number 1. What would you do if you just had to solve this all by yourself? What would you do?
So the denominator.
You would multiply everything by 4, because what will that accomplish? If you times everything by 4, the denominators are gone and you don't have any fractions anymore, right? So why don't I do that? I'll just multiply everything by 4. So times 4, times 4, times 4. Now the reason that you did that, boys and girls, and it's like 4 over 1 is what you're multiplying by, is those will cancel. And these will cancel. And these will cancel. So the equation that you have left to solve is x minus 1 plus x plus 4 equals 3. Everything's gone. We have x minus 1, we have x plus 4, and we have 3. That's all that's left. So what do we do now? So we have over here, we have 2x plus 3 equals 3. So then we will minus the 3. Don't worry, 0 is fine. It's not in the denominator, that's when it would bother me. And then divide by 2. What's 0 divided by 2?
0.
Done. There's your answer. The answer to the problem is 0. These are not graphs, so there's no asymptotes and all that. We're just solving. So we're going to get answers like x equals something. What about this one? What would you do with this one? Deal? I would definitely multiply by x. Now, when you multiply by x, these are going to cancel. That's why you did it, right? You got rid of that x. But what do you have over here? Nothing's canceling over here. What do we have? X squared plus 2x equal 215. What kind of an equation is that? Quadratic. What do we do with quadratic equations? Equal one to 0. Absolutely. Get it set equal to 0. So I'll move the 15 over. And then I have a choice, don't I? What's my choice? I can try to factor it. Do you think this one factors? I think it does. 5 and 3. But if you don't see that, oh, let's see, plus 5 minus 3, because I got to do plus 2 there. If that doesn't occur to you, if you're not sure, what else could you do right here? Quadratic formula. Now, a few of you don't have the quadratic formula memorized. If you're gonna use it, people, you better have it memorized. I am taking no prisoners. If you don't know the quadratic formula at this point, it's wrong. Did that happen to you? Were you one that didn't know it?
No, I'm pretty sure I didn't.
Well, if you didn't, you when you got your paper back, it said, ah, in great big letters. Did yours say that?
I don't think so.
All right, this one factors though, so what are my answers? X equals -5 or X equals +3. Easy, easy, easy. Is the next one kind of the same thing? So Elijah, what would I do first on this? This is problem 3. What would I do first? Yeah, and if I do that, that X cancels, make sure you get rid of it, it's gone. So we have X squared plus 12 equals 7X. And then what? Bring the 7X over, and let's put it where it belongs, here in the middle. It's gonna make it easier for you if you put it in the right spot when you bring it over. This is just like that one. Does this one factor? Into X -4 -3? So X equals +4 or +3. Are you thinking, well, this isn't too bad? Let's look at the next one. Ay, ay, ay. Does anything like strike you when you look at this problem? Do you notice anything? Sydney?
Greatest common factor out of the X squared.
Exactly. So you know how in the problems that we're gonna have a quiz over, what was the first thing we did? Factor, right? Factor, factor, factor. So if something factors in the problem, do that first. So Sydney noticed that we can take an X out of that denominator. So that's what we're gonna do first. Now, when we do that, we notice that these two are kind of close, right? If this one had an X, it would match this one. So I'm gonna go ahead and give it an X, but if I put one on the bottom, I also have to put one on the top, right? You can't just put it on the bottom, I'm gonna put it on the top also. Now this denominator, I'm gonna rewrite this 2. This denominator is just 1, that's 2 over 1. So what does he need? If he's gonna match, he needs an X and an X minus 4, or X plus 4. So I'm gonna multiply this guy by an X and an X plus 4. But of course, don't I have to do that to the top also? So I put an X and an X plus 4 on the bottom and an X and an X plus 4 on the top. Everybody following what's happening here? I am making my denominators match, right? Well, we'll finish this tomorrow, but once you get the denominators matched, you can lose them and solve the resulting equation. All right, have a good day. Office hours tomorrow if you wanna review one more time before the quiz. You go to eight. You go to 8 period right now. Yes, that's not when I thought the bell was gonna ring, but